I'm going to lead you to sort of some shortcuts that has to do with trig, some ways that you can get from like cosine of one angle to sine of another angle or vice versa. Okay? And the first one is called the complementary trig property. Now this looks really confusing to write out on paper, so I want us to kind of think about what we did yesterday. In a triangle, let's say I give you this angle. This is a right triangle, by the way. If I give you this angle, how do you find this angle up at the top?
Minus 90.
Okay, remember yesterday I showed you that shortcut that you could just do 90 minus theta? 90 minus whatever that angle is. So if I gave you a 30-degree angle, you would do 90 minus 30 and get 60. If I gave you a 55-degree angle, you would do 90 minus 55, get 35. Isaac?
If that's a right angle, wouldn't it supposed to be 45?
No, because we don't know that the two angles are exactly the same. They could be. That's a possibility. But they could be 30 and 60, right? They could be 89 and 1. So they could be any other combination that makes up 90. So when you see these things written, when you see theta and 90 minus theta, all that's talking about is the two angles in a right triangle. Because if you call one theta, the other one would be 90 minus theta. So when you look at this first property, this is complementary trig property, it says the cosine of the angle is equal to sine of the other angle. Isn't that what you found in that table? Did you find that the cosine of one matched the sine of the other? Okay. What did you have down for the second question on the back of that activity? Somebody raise your hand and tell me what you wrote. You don't need a new one. Devin? Oh, sorry.
I got it.
What'd you say?
Are they the same?
Well, sort of. Jotea?
A
little more specific.
Flip-flop.
Okay, flip-flopped. Good way to think about it. So you found that when you did the cosine of one of the angles, it matched up with the sine of the other angle. So the cosine of this matches the sine of that. That's what this first property is saying. The cosine of one angle is equal to sine of the other angle in the triangle. And the sine of one angle is equal to the cosine of the other angle. Okay? Jotea?
So, what you're saying is, so how we would get one angle to go from sine to cosine, we would use like what we did here?
Yeah. Yeah. So if I gave you the sine of one of the angles, that would be equal to the cosine of the complement, meaning the angle that you would get if you subtracted from 90.
So would you use B or A?
I'm sorry?
Because you know how there's A and B, and then you have two different angles, and that's how you get
Oh.
the two answers.
Uh-huh.
So would you use the one that's actually the same numbers equal to, or would you use the one across?
It would depend on what you were given in the triangle. You could probably go either way on that. Okay. All right. Isaac, what did you find for that question about tangents? Question number 3.
Okay. So I tried all of the different different equations.
Yeah,
and I found out that if you divide the sine by the cosine, you get the tangent.
Yep. Did anybody else find that? Okay.
Yeah, I did that now.
That was the one that I had asked you to take the sine and the cosine and just mess around with them a little bit. I wanted you to try adding them, subtracting them, multiplying them, dividing them. Too many people give up after like addition and maybe subtraction, and they say, well, I don't know. Okay? But if you had gotten to try division, you would find that when you do the sine divided by the cosine, it equals the tangent. That's what this next property says. And this is going to be more important when we get into the unit circle, that tangent of an angle is the same thing as sine of the angle divided by the cosine of the angle. Isaac?
When I did this, I just did divide first because it just seemed like it would make
Like that would be more possible? That's good. That's good. I'm glad you were able to figure that out. Anybody else? Questions or comments about that? And then the last one, that last question I asked you to do was a little bit hard for me to word. I told you to take the sine and square it, and then I told you to take the cosine and square it, and then I told you to add those two things together. And I told you to try that for multiple things in your table. What did you find every time you did that, Cassidy? Yeah, they should have been real close to 1, like 0.999, right? The only reason they were close to 1 is because you probably rounded your decimals in that table. Okay? what this property tells us is, and this is related to the Pythagorean theorem, because a squared plus b squared equals c squared. Can you kind of see that in there? It tells us that if we take sine of an angle and square it, and cosine of the same angle and square it, and add them together, it's always going to equal 1. And that can be very helpful to us. So now, this first set, these are sort of the easy examples here. This is where you're just kind of filling in blanks with different angles based on the properties. And then we're going to do some more heavy-duty solving down on the bottom. So, I want to know sine of what angle would be equal to cosine of 30? Well, remember that in a triangle, the sine of one angle matches the cosine of the other angle. Okay, that's what that first property is talking about. So the sine of one angle is equal to the cosine of the other angle. So if we have cosine of 30, if this was a 30-degree angle, that would be sine of, what would the other angle be?
90 degrees.
60, yeah. Okay, so this is your 90. So really what I did here is I did 90 minus 30. And I found that it was 60 degrees. Okay? So let's try that same thing for the next one. Cosine of 27, so if this angle was 27, that would match the sine of 53. Oh, 63? I did that first hour too. 63, sorry. So 90 minus 27. Okay? Now this next one, tangent of 45. I don't want you to type tan of 45 into your calculator. I want to know, how would you write tangent in terms of the sine and the cosine? Isaac?
Tangent A equals 1 over 45.
Not quite. I'm not looking for, like, sides of a triangle. That's not where I'm going. Look up here. How did we write tangent up here?
Sine over cosine.
Sine over cosine. So tan of 45 would be equal to sine of 45 over cosine of 45, like a fraction. Now, could you actually solve that and get a number? Sure, but we're not worried about that right now. We're going to do that when we get into the unit circle and exact values. Right now, I just want you to know that you can stack them like that you can do sine divided by cosine. Okay, this next one says sine of 20 squared plus cosine of something squared equals 1. Well, in this that's this property. Can you see that? Do you see how that sort of matches up with that? Are these two angles exactly the same? Is this a theta and a theta? Okay, so those two angles should be exactly the same. So what should this be? 20, yeah.
20.
Okay. And the last one, sine of 50 over cosine of 50. Carla?
1.19.
Okay, again, I don't want an actual number. You're probably right. That's probably what it is. But I want you thinking about the properties. Just how could you rewrite that? It equals tangent of 50. Yeah, it's kind of backwards from this one. Okay? So sine of 50 over cosine of 50 is equal to tangent of 50. Okay? So these ones are what I'm referring to as sort of your easier examples. Okay? And if you didn't think they were super easy, that's okay. But for the most part here, you're not doing any math. You're just figuring out what plugs into the blank. Down here, this is where we're going to start doing some math. Okay? Questions on any of those before we move on? Okay. Now it says use the properties to solve the following problems. Okay, this next one, I would bet right now you would have a hard time figuring out how to start this one, but I hope that after you see it, you'll be okay. By the way, your homework assignment tonight, a very large majority of the assignment is just like these or just like these. So I really want you to make sure you're doing a good job writing these down. And then also make sure when you're doing the homework, if you look at a problem and you're confused and you don't know how to start it, please look back at your notes, okay? Because your notes are really going to help you for tonight's assignment. So if cosine of x equals 52, find sine of x. We need one of our properties that involves cosine and sine of the exact same angle. So look at your three properties, because this is cosine of an angle and sine of the same angle. Okay? Which one of our properties involves sine and cosine of the exact same angle? What do you think? Okay, you're right that tangent does involve sine and cosine of the same angle, but it also involves tangent, right? Do I have tangent anywhere in this first problem? No. Okay. Yeah, the Pythagorean identity uses sine and cosine of the same angle. Now this up here, and that's why I kept emphasizing this is sine and cosine of two different angles. Okay, here I want to stick with that same angle x, but I can use the Pythagorean identity here. And here's what that's going to look like. First, I'm just going to write down what the identity says. So the identity says if you do sine of x, I'm using x instead of theta now. Are you okay with that? X and theta are really the same idea. So sine of x squared plus cosine x squared, whoops, parentheses squared, equals 1. So that's like our formula that we're going to use.
Wait, this is the formula?
Yeah, this is like the formula.
Okay.
Not sine. Cosine, yeah. Cosine is 0.52. So I'm going to put in, let me get rid of all that stuff at the bottom. I'm going to put in 0.52 squared right here. So now I have sine of x squared plus 0.52 squared equals 1. Well, what is 0.52 squared? Can you help me with that? Thank you. So now I have sine of x squared plus points. Can you say that again? 2704?
Yeah.
2704 equals 1. Remember, I'm trying to get sine of x by itself. So what do you want to do now? Sure. Subtract 0.2704. Subtract 0.2704. And so I end up with sine of x squared equals like 0.73-ish. 0.7296. We're almost there. Well, I want sine of x, and I have sine of x squared. Square root it, good. Okay, and so now this square root and this square are going to cancel, and you'll be left with sine of x is equal to whatever that square root is. 0.8 something, I think. Okay, sine of x is equal to 0.85. Okay, so it's just like doing the Pythagorean theorem, where if I gave you this as like your a in Pythagorean theorem, and then I told you c squared was just a 1, you're just solving like you would in Pythagorean theorem. Okay? Okay, let's look at the next one. It gives me sine of x and cosine of x and wants me to find tan of x. All right. Yeah, we know that tan of x is equal to sine x over cosine x. That came from up above. That came from one of our properties. Right?
Yeah.
What's sine of x in this problem?
Sine of
Yeah. 0.848 divided by 0.530. And then let's just do that division.
Wait, where'd you go? Oh,
From the problem.
never mind.
Right here.
I see it.
0.848 divided by 0.530.
don't you have to do the sine equal 1.3?
Nope, because this told me the sine of x is equal to that.
Oh.
Okay? I'm sorry, was it 1.6? Is that what I heard? All right, so that means tangent of x is equal to 1.6. So these are ways that you can kind of transfer between sine, cosine, and tangent without knowing what your angles are. Okay? And then look at this last one. It says, suppose cosine of x is blah, 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 and tan of x is blah, blah, blah. Find sine of x.
Oh, that's the tangent property.
Still the tangent property, yeah, because I'm still looking for one that uses cosine, tangent, and sine. So that's still my tangent property. So I'm still using this tan of x equals sine of x over cosine x. Kinda, yeah, I'm going to cross multiply. I'm going to fill in my numbers where they go. So tan of x is given to me up here, 2.050. Sine of x is not given to me. And cosine of x is given to me as 0.438. So yes, you could put this over 1 and cross multiply, or you could just do what?
Divide.
Multiply.
Yeah, this is division, right? And you're trying to get sine of x by itself. So I would multiply by 0.438 and multiply by 0.438. Sorry to squeeze that in there. I want to say it's like 0.89. Is that right?
Can't you just do the inverse tan of each, or the inverse of each one, and then?
Let me get to that. Yes, you could. Say that number again. I'm very sorry. Okay, so tan of x equals 0.89. Okay, what Colvin is saying is, couldn't we just do the inverse cosine? Now, if I did the inverse cosine of 0.438, what would that tell me? What information would that give me?
What the angle is?
That would tell you what the angle was. That would tell you what x was. And then you could do the sine of that angle. Today, I want you practicing using these properties, because these properties are going to come into play on the unit circle, and you're not always going to be able to do that. So I want you practicing with this. Now, if a question like this were to show up on like your chapter test, and you wanted to just do that, that's fine by me. Okay? Hearing? It is. Thank you. Thank you for catching that. Yeah, it was sine of x that I was trying to find. Whoops. Sorry, I must have been looking up above. I was talking and writing at the same time. Thank you for catching that. Sine of x. Good.